Okay, in this video, I'm going to be talking about arcs and chords. There's first some main ideas I need to give you. Two arcs are congruent if and only if two pieces. Their corresponding arcs are congruent. I'll write out the word congruent. Meaning two chords. So AB is congruent to DC. AB is equal to DC or CD if these arcs that they intercept. I call it intercept. So the measure of arc AB is equal to the measure of arc DC. Okay. So then the other piece of that is two chords are congruent if they are equidistant from the center. Meaning they're equally distant. They're the same distance from the center. So AB is equal to DC if they're the same distance from the center, meaning this segment from my center, EF, is equal to EG. Okay. So that's one piece of today's lesson. Then the other piece, if a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc, meaning a diameter, or a radius. So I have EH is perpendicular to chord AB. So I have I have that chord perpendicular to a radius. Then I know that it bisects the chord, meaning cuts the chord in half. So AF is equal to FB, and it bisects the arc. AH, the measure of arc AH, I don't know why I wrote AC. AH is equal to the measure of arc HB. And similarly, if we look at this other radius down here, EI, if EI is perpendicular to DC, so if I have, again, a radius perpendicular to a chord, bisects that chord, so DG is going to be equal to CG. And similarly, the measure of arc DI is equal to the measure of arc IC. Okay, our first example. We have SR. This chord is congruent to ST. So if I have congruent chords, their arcs have to be equal. So arc, the measure of arc ST is equal to the measure of arc SR. Okay, so what that means is that ST 7x plus 24 has got to be equal to 115. I subtract 24 from both sides, I get a 91. I divide by 7, x is going to equal 13. Okay. Next example. In the figure, circle A is congruent to circle B. WX is congruent to YZ. I need to solve for WX, so keep that in mind. Once we solve for X, we're not done with the problem. So I have congruent circles. So congruent circles with these congruent arcs tell me my chords are equal. So WX has got to be equal to YZ. So WX 7X minus 2 is equal to 5X plus 6. I subtract 5 over, so I get 2X. Add the 2 over, I get an 8. X is equal to 4. I need to solve for WX. WX is equal to 7X minus 2. Well, that's 7 times 4 minus 2. Just wanted to make sure I was doing my math right. 26. Yes, I was doing that right. Okay. Next example. So here now I have a chord. They tell me the whole arc, DEF, is equal to 150. I need to find the measure of this arc. So what I have here is I have a radius. Notice that radius is perpendicular to the chord. That means it bisects the chord. We're not looking for it, but HF is 5. It also bisects the arc, meaning the measure of DE, arc DE, is equal to 1/2 the measure of arc DEF. So the measure of arc DE is equal to 1/2, 150, that equals 75. Next example. In the circle below, diameter QS is equal to 14 inches long. Chord RT is 10 inches long. Find VU. So I'm looking for this piece right here. I'm going to call that X. Okay, so I have a radius. VS is a radius. VS is a radius. And VS is perpendicular to RT. So that means it bisects. Meaning, if RT is equal to 10, RU is equal to 5. Now a diameter is 14 inches. Okay, so yes, QS is one diameter. One diameter that I think students struggle with drawing in also is this whole diameter. I'm going to throw a W in here. So WR is equal to 14. My radius VR then is equal to 7. So notice what we have. We have a triangle there. We have triangle VRU, where I have a little right angle in there. My hypotenuse is 7. One leg is 5. I'm looking for VU. So one leg squared plus another leg squared equals my hypotenuse squared, the Pythagorean theorem. So x squared is equal to 24. I square root both sides. X is equal to root 24. But you know me, I want things in simplest radical form. So break down 24. 24 divided by 4, well, okay, that's 4 times 6. So x is equal to that. 4 can break out of the radical. We can make it 2 outside. 6 has no perfect squares in it. He's locked in his radical. Okay. So EF, in circle P, EF is equal to GH, which equals 24. So I have this segment here equals 24. I have this segment here. So I have congruent chords. Find PQ. Well, if I have congruent chords and and I have a perpendicular, that means those perpendicular segments PQ is equal to PR. Now I think it's a little ambiguous. Okay, 4x minus 3. Is that EQ? Or is that equal to PQ? And I'll be very honest with you, I just recorded this lesson. This is my second time recording this lesson today because I assumed it was EQ. I would tell you in the future that it equals PQ just because it's a little ambiguous, or I might draw a little arrow in there because it's a little unclear. So PQ, which is 4x minus 3, is equal to PR, which is 2x plus 3. I subtract the 2x over. I add the 3 over. X equals 3. Again, I'm looking for PQ. PQ is equal to 4x minus 3. So that's 4 times 3 minus 3, 12, 11, 10, 9. So PQ is equal to 9. Okay, thank you for watching my video on arcs and chords.